All right, so welcome to this video on approximating square roots, Math 8. And what we're talking about today is every number is a real number that we deal with. If I was talking about dealing with numbers that weren't real, like literally fake numbers, that would be imaginary numbers. I want you to know right now, even though you're in 8th grade, imaginary numbers exist, but you'll never really deal with them until you're like a sophomore, junior, senior in high school. And even then, you're just getting the basic idea of it. I actually have a degree in math. I did 4 years of math in college, and I still don't really know what a imaginary number is that much. I sort of know, but they're pretty complicated. So let's talk about every number is a real number in this world. There's two types of real numbers. There are rational numbers and irrational numbers. If you look at the word rational, it says ratio right here. Ratio is like a fraction, okay? So anything that's a fraction, fractional and rational are kind of the same. So ratio means fraction. So if you can write the number as a fraction, it's a rational number. Let's take a look at this guy right here, 2.25. That's 2 1/4, right? This is 0.3 repeating is actually kind of weird, but it's 1/3. So these are all rational numbers. A number that doesn't repeat, a decimal that doesn't repeat and goes on forever is an irrational number. We know the number pi is 3.14. But pi is actually not 3.14. It's actually 3.1415926 ... It goes on forever. Pi never ever ends. What's kind of cool about pi is if you looked at a whole long list of pi, you could find your own area code in that list of numbers, 508. Or you could look at a whole long list of numbers and you could find your own phone number in it. Because pi is an infinitely long list of numbers. So eventually, your phone number, your very personal phone number, will show up in pi somewhere. You might have to look through pages and pages and pages of decimals to get there. So these are numbers that never ever repeat, okay? These are all irrational. But what do you notice about these guys right here? They're all square roots of numbers that aren't perfect. Anytime you have a square root of a number that's not perfect, an imperfect square root or an imperfect square, and you try to take a square root of it, doesn't come out nice and neat and pretty, like 16 and 100 and 121 and 9, or even a cube root, that's going to be an irrational number. So that's what an irrational number is. It's a number that never repeats and goes on forever, a decimal that never repeats and goes on forever. So let's just talk about finding the lengths of the side of this triangle here. So what I want to do is, numbers 1 and 2 are pretty simple. I want to skip down. I gave you a lot of note handouts here. What I want to do is focus on 3 and 4 because they're a little harder. So let's look at 3 and see if we can figure out the Pythagorean Theorem here. We know that the c is this guy right here. So we know that c squared is by itself. So then could somebody tell me what would be a squared plus b squared? Think to yourself, what would be a squared and b squared? Yes. 3.6 squared, 4.8 squared. Cool. Now for this, for our purposes, we'll just grab a little calculator and we'll just do this out because I don't really know what those are going to be. 3.6 squared, I have a squared button over here. It's kind of cool. So that's 12.96. So I got 12.96. And then I'm going to actually do the same thing here. I'm going to do 4.8 squared. You can do it with a calculator, or you can do it with like 4.8 times 4.8. That's 23.04. And that's going to equal c squared. So this is the new equation. I just did a little bit of math out. Now if I took the 23.04 and I added the 12.96, I'm going to have 36. Oh, that's cool. It kind of came out nice for us. 36 is equal to c squared. So what is c going to equal? 6? So it did come out nicely. But you'll notice that there are some decimals going on before we get there. So sometimes that happens. So this is an example where we have some decimals. It's not quite It's not a crazy hard example, but we're using the Pythagorean theorem. Is everybody okay with this example? You can kind of give a nod here. I know since I see a little bit of nodding in my room, I'm figuring that hopefully you at home watching the video are doing fine as well. So we could find the missing side of this triangle, for example. So why don't you pause the video and give this a try. We'll call this a now you try. You can use a calculator on it if you like. It's not like really encouraged, but if you need to, that's fine. So pause the video and give this problem a shot. Good luck. All right, so make sure you pause the video before you go on because it's not going to help you really to look at the answer. But what I want to try to show you is, unless I already did the problem, what I would do is I would write out the equation like this, right? And I would say that these two things equal c squared, right? So that's that part. Make sure I square that. And then I'm going to just do those things out. Oops, sorry. We know what c is, don't we? So I'm going to get rid of this over here. I'm going to put that up there. It's not really helpful. It's actually 2.9 squared. 2.9 squared. So now when you do out the math, you get these decimals right here. And once you solve this out, you get a squared equals 4. So that means that a is 2. And how do we get rid of a squared? We square root both sides. So a is equal to 2 is our answer. So some things are coming out as decimals, some things are coming out as whole numbers. I want to look into situations where they don't even come out that pretty. They come out a little bit worse looking than that. So let's try to keep carrying on. We're going to skip over this one. We're going to classify some numbers for a second. Okay, so I'm going to do a couple of these and then maybe you'll classify one at the end. So we already said pi is irrational, okay? So I want you to tell me whether these are rational or whether they're whole. Can this number right here be written as a ratio? What is ratio same as? It's the same as fraction, right? Can it be written as a fraction? Is it written as a fraction? So this is rational. I'm just going to put rat for like short because I'm a little bit lazy. Okay, these guys, this is a square root that's perfect. So the top guy, the middle guy, C, is that going to come out nice? To a good number. Is 9 on the list? 9 is on the list, so because of that, it's a rational number. Is 12 on the list? Because of that, it's an irrational number. Okay? And now this question is 0.25 repeating. Well, any repeating decimals are okay. So because it's a repeating decimal, I'm going to say it's rational. And then I'm going to say right here, repeating. Decimal. This is okay. So like this, these are all going to be rational if you have a repeating decimal. Okay? So let's talk about this bottom one here, looking at my examples, and tell me whether these are rational or irrational. So take a second, try to figure it out on your own, and then we'll continue. So just take a moment, try to figure out rational or irrational, and then we will go over it in just a moment. Okay? Pause the video and give that a shot. So let's talk about these, okay? Here's the first question, this guy. We don't know if this is repeating really, and even if it was repeating, it's not like it's 12 repeating forever, 12, 12, 12, 12, 12. That's repeating. That would be rational. This is not repeating like that. It does have a pattern, yes, but it's not repeating the same exact two numbers or one number over and over, so this is irrational. I'm just going to put an I for irrational. Look at this number, 196. Well, we know that 144 is on the list, and what's after 144? 169, and then what? Anybody know after that? Yes. So 196 can be square rooted to get you just straight up negative 14. Because of that, it's a rational number. No, because what happens is it's a negative outside of the square root. If it's a negative inside the square root, you can't possibly do it. But when there's a negative outside of the square root, that's okay. Also, it doesn't matter if a number is negative or positive. That has nothing to do with irrational and rational. So a negative number could be irrational, or a negative number could be rational. A positive number could be irrational or rational. what you need to focus on is 196 makes the list, and because 196 is on the list of perfect squares, it comes out to a perfect number, which is negative 14 in this case, and so it's rational. Is there a cube root of 2? If I did the cubes out, would I get 2 on the list? 1 cubed is 1, right? 1 cubed is 1. 2 cubed is 8. And 3 cubed is 27. So because it's not on the list, it's going to be irrational. So any number that's not on the list is going to be irrational. So all we're doing is trying to classify numbers. We'll get better with this as time goes on. This isn't the most important thing we're going to talk about today. What's more important is that we talk about this problem right here. We estimate this to the nearest integer and the nearest tenth. So moving on to this problem, we have to estimate the square root of 71 to the nearest integer and the nearest tenth. I'm going to do 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. I'm going to keep going until I feel I've gotten where I need to get to. 64, 81, and 100, I think. Now, if I look here and I see 71, I put a line right here. Do you agree that 71 is right in between those two numbers? Okay, it's not perfect, so it's not going to come out nice. So there's the square root of 64, and there's the square root of 81. And we know that 71 is somewhere, square root of 71 is in between them. Do you see how the numbers just go up, right? Square root of 71 is bigger than square root of 64, but smaller than square root of 81. So what two numbers is it sandwiched in between? It's sandwiched in between 8 and 9. So the question then becomes, what does this come out to? Is it closer to 81 or closer to 64? Closer to 81 or closer to 64? Closer to 64, right? It's about 7 from that. So because it's closer to 64, I'm going to solve the first part by saying that to the nearest integer, it's closer to 64. So the answer is, to the nearest integer is 8. It's closer to 8 than which is 64 squared, right? 8 squared is 64. But now I want to round it to the nearest tenth. So when I round it to the nearest tenth, can you tell me, would you say 8.5 as a guess, 8.3, 8.8, 8.1? What do you want to try? 8.4? Let's try 8.3. It's right in the middle. We had somebody said 8.1, 8.4. I'll try 8.3 question mark.
It's not 8.1.
So if I do 8.3 times 8.3 real quick, and I'll just do it out in math like this, long way. 9, that's 24. 0, that's 24. That's 66. So I get 9, I get 89, I get 8, this is what I get, 68.89. So maybe it's 8.4. Let's see if 8.4 does it. So if I do 8.4, which is a little higher, do I get a closer number? 16, 32, 33, and then what do I get? 8 times 4 is 32, 66. So I get a closer one. I think 8.4 is our best bet. That's our closest number to the nearest tenth. It's closer to 8.4 than 8.3. So that's just estimating the square roots. So that kind of wraps up what we need to be able to do. We need to be able to get estimates for square roots and whole numbers and classify rational from irrational. So we're going to stop the video there. I'll see you in the next video. Peace.